This is Mohammed Saibinamdar Prohor back again with another video. So today we are gonna talk about Pandas Basics 2, and our today's topic is handling missing values. So in last session I talked about how to display the values or data from the CSV file, and now we're gonna talk about how to handle missing values from the datasheet. Like sometimes or all the time we don't have all the data from all the sections or all the rows or all the columns, so we have to handle those scenarios, right? Because of those missing values, our maths or our data gives us wrong prediction. So at first we need to know which data are missing from which column and which rows. So in pandas, we have a function which is called is null. So by using this function, it shows true or false of data if they are not there. So if it shows true, that means that particular data is missing from that particular row and or particular column. So let's run this function. Yes, as you can see that everything here is false, 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 but this is true. And yeah, and that's it. This particular row is true. So what is this? Let us see. As you can see that it is nan. That means it doesn't have, it is missing that value. So let's run is null dot sum. So this function shows how many truths are there of each column. Let's run it. As you can see, uh, a age column is missing one value, gender column is missing one value, and witness column is missing one value. And other than that, all the values are there. So let's describe this scenario by using the numerical data. As you can see, for our age, it showed us the how many data are there, its mean, its standard variation, deviation, its minimum, 25 quartile, 50% quartile, 75% quartile, and maximum. So let's see the information about the dataset and identifying which data type which column has. If the max data one matches with the found data, it means it's missing. As you can see that the age is float and every other data type is object, right? So let's create a copy of the dataset, because like list, if we change the main dataset, it will affect the main data, which is why we are creating copy for experimenting our methods. Now, if missing values are less, deleting is missing or less, deleting the whole row which is missing the data. If missing values are more, then just replace the data which is suitable. So if the missing values are less, we can just delete the whole row. But if the missing values are more, then we just have to replace which are suitable data. So df1, which is our copy of the main dataset, we will just drop the subset of age, and in place is true. It will drop the whole row. We are also dropping the gender and witness, because those three are the rows which are missing the actual data. And then if we run it, and then if we see the sum, we deleted the missing values, right? Because we deleted the whole row. Moving on, if we see the length, it's less before after delete the missing values of rows, because before it was 590 520 and now it is 570, because three of the data have been deleted. Now without dropping the values, we will add the mean and median values, and for categorical value we will use the most frequent data of that column. So for age, with this fill now function, we fill that void with the specific mean. We replace it by its mean. And then let's move on. Yes, we fill that void with the mean. And for gender, which is a most frequent category, like male and female, we fill it with the yes. So now, if we apply those, you can see that right here, this is the mean data, right? At first it was none, but now it's the mean data, which is 49.082582. If we move on right here, as you can see, this fill the void which it was missing. That's how we handle the missing value. Either we drop that particular row or we fill it with the mean or the most frequent data of that row. Now, handling categorical values or encoding. So our computer or our PC doesn't understand the English language, right? So we need to transform it into it a numerical value, so it can calculate or it can predict various things, which is why we need to encode those data into numerical values. Like right here, male and female. That means we can encode it into 0 and 1. 0 means male and 1 means female. So then the PC will understand if for the gender column 0 comes out, it means it's a male, and for 1 it will be a female. And for no and yes, it's always 0 and 1. 0 means yes, or 0 means no, or 1 means yes. That's how we will encode the whole data set. Now, to encode the data set, we will use sklearn. Sklearn or scikit-learn is a Python library. So from there, we will use import label encoder. So label encoder is a process of labeling which is making categorical value numerical. As I said earlier, male equal to 0, female equal to 1. Now let's import scikit-learn preprocessing and label encoder. Let's run it. And right now, by using label encoder dot fit transform and our specific column, it is transforming the whole data set into encoded data. So by using fit transform, it exchanges the encoded data to main data. Now, if we run it for our info, as you can see that all the data sets are transformed into integer value. At first, it was object. See, it's all object. But right now, the data sets are transformed into integer, which are labelly encoded. So let's just see df dot head 5 columns. Oh, okay, the automatically 5 column. See 0 1 0 1 0 1 0 1. It is encoded of every data. Now moving on to one hot encoded data, it will create us a dummy data set by putting on every column. And now if we show the data set, you will see that we divided the data into two categories, right? As you can see, gender 0, gender 1, gender 2. Then polarea 0, polarea 1, which is true, false, true, false. It turned all the category into the numerical value as well as the value of each columns. So this is a term which is called one hot encoded data. Now if we see the info, everything is turned into a Boolean data set. So these are the two types of encoding, which is one hot encoded data and another is label encoding. So label encoding is transforming every column into a numerical value, and this is transforming every category into numerical value as well as the value of each column into a boolean form. Now, sometimes we face imbalance in dataset. So this is a another problem for another video. So thanks for staying with me, and we will come back with another video of talking about handling imbalance in dataset. Thanks for staying with me.